Well, hello everyone. How are we doing today? This is a little presentation about laser cutters and some of the things that they can do. You should have already seen the first video introducing what is CAD and seen different applications of different types of CAD software in industry. And that was a high school teacher, middle school teacher showing you his perspective on CAD. I thought it was a really nice 10-minute video introduction. And then you saw a video on examples of CAM, computer-aided manufacturing, and three primary pieces of equipment that people have in schools, even though there's more. But anytime one of those machines is running by itself, following the design for how to cut out or build up layers of material to come out with a 3D product, we call that CAM, computer-assisted manufacturing. And those types of equipment are called rapid prototyping equipment because we can make a prototype or a model fairly quickly. Now, I guess that's kind of a misnomer because 3D printers are so slow, right? But the focus in this video is going to be laser cutters. So I'm just going to show you examples of some things I made in my classroom over the years, and you can see how some of those projects evolved. And I want you to know that when it all started out, I had no idea what was going on with the laser cutter, but somebody came to my school, made a presentation, and they were showing off these pieces of equipment here. They had brought some epilogue lasers to demonstrate, and we thought, well, we don't really know about any other types of lasers out there. I think you used a universal laser up at the makerspace. And these machines can have a big huge bed like the one you saw, where you can drop a big sheet of material in that's 2 feet wide by 3 feet wide. And the thickness of that material, you used a thin sheet of material to cut out those keychains, but in these big machines, you can actually put something in that's a foot tall. You can drop half a tree stump inside of one of these things and engrave the top of it. The other coolest thing I thought about the laser was that in the demonstration I saw, they had taken a piece of paper and put it in there and actually engraved the paper with a watermark, and to make it look like it had a watermark on it without going through the paper, without lighting the paper on fire. And I was like, wow, that's amazing, and then it would cut the paper out as well. And then they showed it with a variety of other materials. And the idea was it's just a CO2 laser. So carbon dioxide is in this cartridge that's built into the back of the laser. And when electricity runs through that carbon dioxide gets excited and creates a photon beam. And that little beam is what shoots out and bounces around on the little mirror lenses, and then comes out of the head of the cutter engraver. And you watch that thing move around. It just moves around back and forth, left, right, left, right, left, right, like it's a dot matrix printer, And that's how it was explained to me when I first saw it. Think of this as a dot matrix printer, except instead of shooting out ink, there's a little CO2 laser. Okay, cool. So one of the first things we did was take a bunch of big old sheets of acrylic that we weren't doing anything with. Let's start this presentation up here. And there was a business in town, and they wanted some signs, and so we had these big sheets of acrylic, and we just went into what we have at the time, Adobe Illustrator, and so the sheet of acrylic was 2 foot by 3 foot, so that's the size we made the document, and then we just laid out some lettering and engraved right on the front surface of it. Realized later it'd be a lot cooler if we engraved on the back of it and then put the letters up on or engraved the letters on in reverse, so that you could just run your finger smoothly across the surface of the piece of material without having to feel the engravings. But the idea is that if you put some LEDs or light up against the edge of the sheet of acrylic, whether from the top down or from the bottom up, anywhere that's engraved, it will pick up that light or diffuse that light. So there's two of the signs hanging in the windows, and there's the regular sign in the middle we made as well. We cut all those little pieces and letters out and then glued them onto a board and mounted them up there. They also wanted some letters they could put on the back of their vehicle, and we took rolls of vinyl and this kind of stuff that goes to a vinyl cutter. And instead of cutting it with like a Cricut machine, or which didn't exist at the time, or a vinyl cutter, we cut them out with a laser, which you could totally do. But if it's a good thing we have the exhaust on the machine, because if we don't have the exhaust, um, I think if you cut out PVC lettering, it makes polyvinyl chloride gas, which is no bueno. But we didn't do it. We didn't hurt anything at the time. No harm, no foul. But again, first time using this machine, started cutting out more stuff. Started building little bases that we could stick LED lights in, so that you could sit the plaque inside to pick up the light. Make it kind of a cool way to hide the battery pack down there. This was a piece of Corian, like the stuff a sink countertop is made out of. And we found a business that was throwing out a bunch of chunks, big scraps. And to them, scraps were these gigantic pieces. That piece right there is like 2 feet tall by 1.5 feet wide. And we found a photograph of Charles Dickens, like a pencil drawing of him or something. And, it was a grayscaled image. And since the Corian was actually a piece of white Corian, if we went to engrave his image into there, it wouldn't have shown it. There was no contrast. It just looked the same color when you engraved it. So we spray painted the surface of the piece of material black, and then took the image, and before we engraved the image, we reversed the image, right? So we have this picture, and in the picture when we reversed it, it turned all the blacks to whites and the whites to blacks, and gave you this reversed image, so that when we engraved, it would remove away the black and reveal the color white underneath. That was Charles Dickens' head. And then the laser cutter also cut the head out, and then we mounted it up here to this big sign that was being made for a bar in Fishtown. Yeah, the kids were getting commissioned after the first year having this laser cutter to make giant signs for bars. I had kids making eagle signs for bars, and the eagle sent out like a cease and desist letter because my kids were selling edge-lit acrylic signs for $800. Yeah. And people would come in, and it really, a lot of it started off with making money for our club. People would come in, they'd have a design they were interested in. We would come up with a design brief for them and some sketches, and then a lot of engraving and cutting, and then taking the pieces afterward and painting them and maybe mounting them to signs. We probably engraved the back of every kid's cell phone in the building that month. There's some colored acrylics. It's really cool if you cut a shape out and then you engrave with that same image, or cut that same image out somewhere else. You could take the cut out and it will pop right back into the one that was cut out. So that's what we did. We cut the letters out. And there were holes for them, and they went to another piece of acrylic, a white acrylic, and cut letters out of there as well, but then pop them back into the ones in the blue spot. Acrylic's great, plexiglass, because not only can you engrave it, but you can also heat it up and bend it, and then it will hold its shape because it's a thermoforming plastic. Thermoforming plastic. So you can change its shape when you heat it up, and when it cools, it will stay in that position. And we were also making slotted furniture or slotted furniture models, where the design challenge says that you're going to create this 3D product, but it has to be something that's flat and comes as flat packaging, so it can be shipped out in a box flat and then assembled later. So you'd be putting slots into things and little key marks and stuff, so that piece of material could be assembled together into a 3D model. You could engrave glass. Probably not as efficient as etching cream is for engraving, but super cool if you want to engrave something and then come back over and put a little paint into that spot where you engraved, or leave it covered up with masking tape, cover the whole thing with masking tape, so that when you engrave, it burns away the tape and you're left with this spot that you could take a paint roller over and then remove the masking tape later. Businesses that would donate to the projects we were doing in school, we'd make signs for them. Bar tops. This is kind of something we engraved the letters, and then we took some paint and put it in a little plastic syringe, not with the needle, but just the plastic syringe part and the plunger, And then if the thing's sitting down flat on a surface, we could inject some paint into there, and it would self-level and take up the space of the letters. And then we'd put epoxy over this thing so they could serve drinks on it. Every piece of scrap material became something somebody could make something with the laser. There's a material called two-tone plastic. Different companies make them, but the idea is that when you see those signs over the door that have the door number and stuff in a school, with the teacher's name and a plaque on the desk, or any plaques hanging up on the wall, two-tone plastics have one color of plastic on the surface and another color on the bottom layer. So when you engrave, it removes away the first layer. So in this case, it was two-tone that was supposed to look like brushed aluminum, even though it's plastic, and underneath black. So engrave away the aluminum color, and you get the lettering and the images. A mirror is just a piece of glass, and on the back it's painted with a chrome paint. So when you engrave away the chrome paint on the back, which means that we'd have to engrave the letters in reverse, right? So they're a mirror image of themselves. So that way, from the front here, when you run your fingers over the mirror, you don't feel the letters because they're coming through from the back. Again, every kind of material out there became something that could be engraved and cut out and made into gifts for people, or to help out with stuff going on around the school. These are little magnets for all the bus drivers. Would show who was working that day. They would take their magnet and pop it up on the schedule that they had set up in the room. We found out that black crayon, when you engraved it, it would leave behind a grayish color. That was for some Boy Scout project. You'll learn more later if you get into it with laser cutters. You know, you can take images and in software you can break an image apart. And when you found vector graphics, those are graphics that were made up of all kinds of lines. You can even search specifically for them just in image searches when you do on Google. And those vector graphics are great because a lot of them will have this really complicated image, and you find out it already has a nice outline around it. So you break apart that image and just pull that outline out, and now you have a perfect outline to cut something out with. And you could do a lot more with them, vector graphics. It's a piece of stone, sandstone, or not sandstone, some limestone or something, and I think we took black spray paint, painted the surface, and then literally engraved away everything but the letters and the picture. So I just have a couple more pictures to show you from another slideshow here. Let me pull this up and see what we got on this one. What I want to show you from in here. At one point I had kids, once they realized they could engrave just about anything, they were coming down with frozen chicken pot pies and taking pictures of each other's faces and engraving them on the top of their lunch. There's a fixture that comes with most of those laser cutters, or you can buy it separate, and it will accommodate something round like a glass, and will actually turn the glass for you. It automates the turning of the glass, and so that you can engrave onto it, or baseball bats, things that need to go around. It's called a rotary jig. Excuse me. Okay, here's what I was looking for. This is a guitar pickup cover or shield. So if you want to make this bigger, if you're working on if you have an electric guitar, you'll see that there's a little cover. The pickups have a cover over them. That's a piece of chrome, so it's a chrome part. It's metal that's got some nickel in it and makes it shiny. That's a piece of looks like a chrome plated part, right? So you can see that stuff those kind of like pieces on like motorcycles and appliances and all kinds of stuff. And you can't engrave metal, like I said, but you can spray paint the metal with a special type of marking paint. And there's a bunch of companies that make these marking paints. And the paints don't look like much when you spray them. They just looks like they're just white. And I'm going to show you a picture of this here. Yeah, there's one. Very expensive. So this is some sear mark spray. You can see there. Sear mark. That's the product, right? And you spray that onto the surface before you engrave. And we know, right, you're not going to engrave through the metal. But what happens is when the laser cutter hits this paint, the paint photochemically bonds to the surface of the metal, right? And it doesn't look like much, but when it gets done engraving, you pop it out or pull it out of the machine, and voila, there's this image here now of the dinosaur left behind, and you can't get it off. It's permanently on there. And they sell paints that you can use for various ceramics as well as metals, and even woods too. It's pretty cool. All right, back to the side. Shrink this back down. There we go. So in this particular classroom, the laser cutter was being used for point-of-purchase displays. Kids had to design, marketing and advertising stuff that could draw attention to a product or maybe integrate it with light. We were making stencils. What do I mean by a stencil? You picture something like this thing here, just a piece of plexiglass. It still has the paper that comes on top that keeps it from being scratched. We engraved away the letters for Wilson's Soap Company, and then that guy used that as a stencil to paint his brand onto his package. So he would just hold that over something and spray paint and leave behind the stenciled image. Then we found out we could do that with images we found online. There's Marilyn Monroe. So we found an image of her online, and then in Adobe Illustrator, there was one click you could do to make a high contrast image. It would take all the black colors, dark colors, and make them black, and anything that was less than 50% black or gray, it would turn white. So high contrast image, it comes out just as black and white image, and then we would cut away the pieces and leave behind the stencil. So this was a student trying to reproduce like an Andy Warhol type stencil. All right, so those are just a couple of quick examples. There's so many things you could do with the laser. Ours ended up running 24 hours a day. Kids were queuing up jobs to run when school got out. Big jobs that would run all night. And you could make 100 keychains in one pop, excuse me, from a sheet of material, and have that design done in a couple minutes, and then run the job in a half an hour. And next thing you know, you got enough keychains to go sell to everybody at the soccer game outside. Just a real great revenue-generating piece of equipment. And then in the classroom, there was no end to how kids would find creative ways to use it and integrate it into projects. That's about it for this morning. I probably went on too long already. If you made it this far, thanks for watching everything, and I look forward to seeing you next time.